So what we're going to cover in this webinar is an overview of our soil health benchmark study. We'll be talking about how we're measuring soil health through this study. I'll go over a few case studies of participating research collaborators. I'll be sharing some graphs with research insights that we've learned so far, and I'll be sharing how you can get involved with this study. I want to mention that if you have any questions throughout, feel free to chat them. I'll do my best to follow that window as we go along, and maybe after each section, I'll ask if there are any questions as well. So to get started, what is sustainable agriculture? We all have probably seen this three-legged stool of sustainability before. 3 legs of importance: environmental, social, and economic factors. When we've asked farmers how they want to measure sustainable agriculture on their farm, these are the 3 topics that always come up. And so today we're talking about that soil health leg of our research initiatives. I also want to put a plug in for the farm financial viability. Real quick before I get started on our soil health benchmark study, there is an exciting opportunity through the Pennsylvania Department of Agriculture called Farm Vitality Grants. This is a $10,000 planning grant for any farm to help them better sustain themselves and to get a deep dive of business planning opportunities. PASA is partnering with Kitchen Table Consultants to offer some services for farmers that apply to this grant. Through Kitchen Table Consultants, farmers will be able to create accounting systems for long-term success, get some detailed business planning and consulting, and also can also get a deep dive into benchmarking with peer farms. We have an ongoing diversified vegetable financial benchmark study, and if you're a vegetable farm, we'd plug you into that study and be able to do benchmarking through that study, comparing you to other farms in the study. This is an exciting opportunity, and anybody can apply. There is more information at our website, the Financial Benchmark Study webpage, and applications are due April 3rd. You can find out how to apply on that website. We are making it as easy as possible for farmers to apply and offering support through that process. So if you have questions, you can please be in touch about that. So back to soil health. This slide's a little blurry, but this is just relaying some of these 4 core soil health principles that we all probably try to utilize on our farms. Maximizing continuous living roots, minimizing disturbance, maximizing soil cover, and maximizing biodiversity. And these are different soil health principles that we are trying to quantify for farmers through our soil health benchmark study. So to get into the logistics of the study and how it works, there's 2 main components for gathering data. One is taking field soil samples on every participating farm every year. We choose 3 research fields. And the other component is then also gathering farm records from these farmers. They include these 3 main components of field management: soil disturbance, crop rotations, and soil amendments. This is a graphic showing how we've expanded our soil health benchmark study over time. 2019 was our 4th season of sampling, and when we started in 2016, we've had 12 farms. In 2019, we expanded to nearly 100 participating farms, and also with help, we expanded into Maryland. We have right now 3 different cohorts of farmers. We have a vegetable cohort, pasture livestock cohort, and a row crop and grain cohort, all participating in this study. We use the Cornell Soil Health Test for testing our soil samples. Every sample gets sent to Cornell University. We really like this test because it has it tests for indicators within all these 3 core soil properties of chemical, biological, and physical properties. Cornell is also great in that they give each value, lab value, a specific rating. And you can see that little graphic on the right there as an example of the ratings that they would give each of your indicator tests. And these are compared against other farms with similar soil types. In terms of what we do with the field records that farmers give us, we create some soil management indicators. You can see on the left, we capture days of living cover, and we get this information from the planting dates that farmers give us. You can see here that we're just trying to capture how many days of full living cover does each field have. Another management indicator we capture is a tillage intensity index. The way we do this is we assign a tillage value, you can see there on the right, to each implement that a farmer uses in the field. This value is from an NRCS table that gives each implement a value based on the amount of soil erosion that practice could cause. And we weight this against the percentage of the field that had this implement go over it. Another component of our soil health benchmark study is to create a community of soil health learning circles. We have year-round opportunities for each participating farmer and each cohort to meet with farmers and share successes and challenges. Through our learning circles, we've developed a series of soil health case studies focusing on one particular farm and different challenges that they may be having. These are easily found on our resources webpage. Another component that we give farmers participating in the study is what we call a soil health infographic. You can see here, this is an example infographic from a pasture livestock farm. This is a piece of material that we give to farmers so that they can communicate all the great things they're doing for soil health on their farm to customers or other stakeholders. We provide their headline numbers and rate them against some average Pennsylvania farm numbers that we've calculated. And this is customized for each farm. Some of the next steps for the soil health benchmark study that we're going to be focusing on moving forward is incorporating measuring water resiliency. We know more than ever now that the weather is uncertain, it's changing, and that water resilience for farm fields are an important part of maintaining proper soil health. We've partnered with Stroud to trial some different water resiliency methods, and what we will likely be focusing on moving forward are some infiltration tests. We'll likely be incorporating these this year into the study on a certain number of farms. And so we'll be using double ring infiltrometers. You can see the picture of an infiltrometer on the left there. And the graphic on the right is just an example of how water infiltration can improve with different soil health practices. Another way to measure water resiliency that we've been working on with farmers is water walks in farm fields. So this is a kind of big field view way to understand how water may be flowing in your field, or how it may be absorbing in your field. After a significant rain event, different farmers will walk through their fields and capture effects of rainwater that they may see in the field, of rill erosion, which is just a channel moving through the field, ponding, and high saturation. And so back to a little bit more about how the Cornell Soil Health Test works. Are there any questions before I move on? Okay. So as I said before, the Cornell Soil Health Test tests for different indicators within these 3 soil health properties. And I'll just put all these on. We, in terms of soil health, understanding the soil processes that each of these properties brings to the table is so important, and really provides optimal soil functioning. So you can see that purple house represents all the soil processes that physical properties of soil can bring to the table. The green box shows all the important biological processes that are part of a healthy soil, and then there on the right is all the chemical properties, nutrient properties that are important. In terms of the indicators that Cornell tests, these are the 10 that we get performed on all our soil samples. Chemical, pH, macro and micronutrients, physical, we test for texture, aggregate stability, available water capacity, and then there's a series of different biological tests that each soil sample is run through. I'm gonna just talk briefly about some of them. So physical indicator, this is the percentage of sand, silt, and clay that is in each sample. And we know that this is important because these are inherent soil properties that can affect many different soil processes. Available water capacity is another physical indicator that is tested for. It's an indicator of the range of plant available water that the soil can hold. Wet aggregate stability, we're discovering that this is more and more important with the uncertain weather. This is a measure of the extent to which soil aggregates resist falling apart when hit by precipitation. Unstable aggregates will pass through a porous sieve. And aggregate stability down here, so important in the relationships to all these different soil functions. Compaction, drainage, bulk density, water storage, resilience. Organic matter, this is still one of the #1 biological indicators you can test for. It's measured by loss on ignition. It's a measure of all carbon containing material that is or was derived from all living organisms, including plants and soil organisms, and it captures living, dead, and stable organic matter. The ACE soil protein index is a different way to view how much soil, how much nitrogen may be available for use from your plants. This is because soil protein is the largest pool of organic nitrogen, and having these values may indicate what, nitrogen could be available for microbes to decompose to make available for plants. Soil respiration is a measure of the metabolic activity of the soil microbial community. And we know that soil microbes are so important in many different soil, healthy soil processes. And so having this indicator can give us a pulse of how rich the soil microbial community is. Active carbon, this is a different way to look at soil organic matter in your fields. This is organic matter that is a readily available source of energy and carbon to the food web. And this is, you can kind of think of this as a kindling for a fire. And this can be a leading indicator of changes in soil organic matter. And this is just another recap of the 10 different indicators that we test for using the Cornell Soil Health Test. Like I mentioned earlier, each test value is given a rating. This rating is developed by using a generalized scoring function. You can basically think of this as a percentile. For example, here we have an example of active carbon. If a farm had an active carbon rating of, say, 600 parts per million, that score would maybe be around 60, and you could think of it as 60% of all farms with a similar soil type had a rating of 600 or below. All right, if there, please let me know if you have any questions about how the soil tests work. And if not, then I can move on to our first case study. All right. This case study number 1 is from a vegetable farm in Northeast PA. You can see here it's 20 acres in production, fairly significant CSA numbers and some wholesale operation. It's been in operation since 2008. And the important thing to note here is that it does have loam soils, but it also has some fairly significant slopes on the farm. So we're looking here at the results of their Cornell Soil Health Test for each of their 3 research fields. You can see the values of each test are circled there in the red, and the ratings here are in this graph are circled in the red. The red is constraining or low level rating, and the dark green is a optimal rating. So each field has some different challenges to it. If we look at the Cornell ratings in comparison with the system descriptions here below, there are some themes that start to arise, and I can try to point these out to you. One of them is that we see that field D3W had some overwinter cover crops into fall brassicas, so some really significant long-term living cover in that field. And as you can see here in the Cornell Soil Health Test, that the aggregate stability was the highest of all these 3 fields. So we can start to make some connections or comparisons to that, we can see here that this farm uses, this is mushroom compost. They use a lot of mushroom compost for the fertility needs. And you can see that they do add a significant amount, 12 tons per acre on 2 of their fields. And this can add, depending, on the additions of this compost and the fertility needs that they're trying to meet. This could play into the fact that they had some pretty low phosphorus ratings here in a couple of their fields. You can see here though that in field E3, it had an optimal rating for their phosphorus levels, and this is one field that is significantly more sloped, and a theory was presented that this could be why the phosphorus ratings are not as constraining in this field. If we look here at their soil management indicator results, as I mentioned, field DW3 had some really significant days of living cover, and you can see that this is reflected in this data. It's over 100 days more than the other 2 fields, and that is, we think, reflected in the ratings that Cornell gave this field. So the challenges for this farm really center around some excess phosphorus concerns, mainly through the addition of their mushroom compost. You can see here that if they're trying to reach a particular goal of nitrogen, this is maybe putting some unneeded phosphorus on their field. And also another challenge is some inconsistent cover crop establishment. That is really reflective in the days of living cover that we saw in the previous slide. So some solutions that this farm has come up with is perhaps they could cut back on mushroom soil and find some other alternative sources of fertility, really to make cover crops a big priority, and consider some fallow years with really long-term cover crop establishments, potentially on maybe some of these ground that is significantly sloped. And then considering a hard stop for vegetable rotation as a way to continue to incorporate more cover crops within their field operations. The next case study that we can look at is a mixed vegetable farm in South Central Pennsylvania. This is a smaller farm, 7 acres. Originally some conventional corn and bean ground. Farmers markets in the Metro DC area. And soil conditions of this farm consist of loam and silty clay loam soils, some of them low-lying along a floodplain. So here we have their Cornell soil test results and some of their soil health, soil management systems below. You can see here that some of their biological indicators and physical indicators are more on the low end of the ratings, and this could be very well due to the fact that this farm is dealing with some wet conditions. This S4 is a low-lying field, and W14 and W9 have some fairly significant amounts of clay within their soil. You can see here that this farm does a really good job of cover cropping trying to get cover crops on every fall and carry them into the spring. But that's still not enough in terms of potentially using them to help with the increasing some of their biological indicator ratings and results, potentially due to their existing soil conditions. As you can see here, here are some of their other results. Days of living cover, fairly significant. They do have some pretty high tillage index ratings. The black dot is an average of all the other peer fields. With their persistently wet conditions, they often find that the rye grows aggressively in the spring, and sometimes it takes a lot of tillage work to get that incorporated. So the main challenges for this farm, cover cropping techniques that can avoid some of this really aggressive spring cover crop growth, particularly with rye, and then managing this within persistently wet field conditions. And some solutions that this farm came up with in a learning circle. Perhaps they could experiment with winter kill cover crops, such as triticale and clovers that might not have aggressive spring growth. Laying black plastic in the fall could help them get a jump start on spring without much spring tillage, and potentially looking for more significant solutions in terms of investing in tile drainage in the most troublesome fields. I'm going to move on to some of the data that we've collected thus far for the soil health benchmark study. What I'm going to go through is some pretty big highlights that we've seen thus far in our years of doing this study. The graph that you're seeing right now is looking at aggregate stability ratings on vegetable farms. The headline of tough weather being tough on soil is definitely perhaps the theme of this. Is data from looking at 2017 to 2018 when weather conditions changed so much in terms of rainfall, and we saw that reflected in aggregate stability ratings. It did drop quite a bit on our vegetable farms. But you can see here that organic matter ratings were much more stable, and this was quite encouraging, as we know that organic matter is quite important in terms of maintaining and potentially improving aggregate stability. But an exciting result of 2019 data that we have thus far is that aggregate stability ratings bounced back. So this is a great example of how healthy soils can be quite resilient. And this graph captures all farms from the study. Each gray dot is a separate field. This is a graphic showing that there are quite a few different paths to good soil health. We're looking at the tillage index compared to organic matter ratings of all fields in our study. We're looking at grazing dairies, row crops, and veggies on this graph. And you can see what's striking about this is that there are some vegetable farms, which we know have intense tillage operations that are still able to maintain optimal levels of soil health up here in the right corner. Another striking point of this graph is that we have our grazing dairies that are nearly all up here in the left corner in the optimal range. So healthy soil can be compatible with different types of tillage systems. This graphic is showing that we still need to keep an eye on aggregate stability. However, in relation to tillage, we're comparing the tillage index of every farm compared to the aggregate stability rating given by Cornell. And you can see that there is a negative correlation. The more intense tillage you may be doing, the less aggregate stability you may have, as you can see here from the vegetable growers that are located in the right-hand side of this graph. This graph is showing that a lot of farms in our study do have optimal organic matter, which is great. And this is in particular highlighting that grazing dairies are definitely do have the highest. This can speak to the power of a perennial system and a 365 living cover. This graph is showing that, again, that there can be problems with low aggregate stability on veggie and row crop farms compared to grazing operations. A lot of farms we're finding are able to maintain optimal phosphorus issues, which is a really important issue in Pennsylvania in regards to water quality. But we're also seeing here that there are many farms across all three cohorts that are having different issues with excess phosphorus. And so now how can you participate in our soil health benchmark study? We have 2 tiers. We've got of participation, research collaborators, and a community scientist tier. There are some key differences, and for research collaborators, PASA works with each farmer to design a sampling strategy and to choose 3 research fields. And we train farmers to help us take soil samples year after year. We provide funds to get these soil samples tested. We do ask farmers to maintain detailed management records, and we also, through the soil health test results and the management records, we generate a detailed benchmark report, benchmarking your farm against all other farms of similar operations. We hope that farmers can participate in our year-round learning circles, conference calls, and our in-person workshops. We've been strategically growing our study and getting more research collaborators to join us year after year. We are currently hoping that we can get some more conventional vegetable and organic row crop farms for 2020. However, if you are interested in being a research collaborator, we'd still like to know if you have an interest in this. Another tier that farmers may be interested in if wouldn't be able to be a research collaborator is a community scientist. So this is similar, but some key differences. The farmer chooses the sampling strategy and a field that they would like to get sampled, but follows the soil sampling protocol from PASA with support from us. Farmers would pay for the Cornell soil health test. And we would ask that you share the results of this and also share management records if you would like with PASA. In turn, we will share our community benchmark statistics from our study with our cohorts of research collaborators. And by sharing this, each farm would be able to then take their own results and benchmark against the study results. But farmers will still certainly be invited to participate in learning circles and conference calls and any in-person meeting. If you're interested in participating, you can please visit our Soil Health Benchmark Study research page, and there'll be a link to a survey that you can fill out and let us know you're interested in participating in either capacity of the Soil Health Benchmark Study. That's all I have. Thanks for taking part and listening. I'd be happy to answer any questions. I have one question that says, will we be able to share this slideshow and materials after? And yes, we can do that. And I have another question. Are you studying any farms using biochar as an amendment? I don't currently believe that we have any farms that use biochar as a significant soil amendment. I also have a question here. Can you go into more detail on the importance of aggregate stability? Sure. Aggregate stability is important in many ways in terms of importance of physical properties. It can create a good aggregate. Good aggregates in your soil, good texture, promote lots of airflow and water flow into the soil, which is important for plants and the soil microbial community. Having lots of different big and small pore spaces also provide lots of living spaces for different parts of the soil microbial community. Good aggregate stability also supports a deep root growth, whereas soils with more poor aggregate stability may have more potential to become compacted, and thus that can really limit the ability of deep root growth, and again, it can limit the proper environment for soil microbes to really thrive. I have another question here of viewing the webinar again. This webinar will be available on our website under our resources page. And we have a question here. How can we obtain a copy of the one-page custom overview showed earlier in the presentation? I believe that's speaking to the soil health infographic that I shared as a product that we provide all research collaborators. That is developed after we get all of the data organized and crunched and analyzed, and that comes to every farmer participating when they get their benchmark report, which will happen in the late spring or early summer. Are there any other questions? Oh, I see a couple more here. Sorry, I didn't scroll down far enough. There's a question about how does excess rainfall change aggregate stability? This is interesting. We found that we think that, as I said earlier, that this was a case in 2018. We think that, you know, the amount of rain that we got in 2018 and just saturated soils. And for example, even though many of our row crop farms are no-till, they still have low aggregate stability ratings. And we think that just the saturation of the soil just broke apart some of these, the soil aggregates. And so hopefully that answered your question. Let me know if you need some more information. I have another question here. Half-acre community urban farm. Most of our beds are raised and we create our own compost. And the whole farm is built upon an old lot. However, water is a consistent problem and the beds don't retain water well. What is the best way for us to promote water retention? I think there's perhaps maybe a couple different ways. I'm not sure if you use cover crops on your farm, but a lot of farmers have found that that helps create some, again, promoting some deep channels, deep tap roots that can break through the soil and can help promote some water absorption and retention that way. A lot of farms also just use a lot of mulch sometimes if they're to just help hold water in their soil and keep the soil covered, and that can help promote water retention. And then I have another question here. Can you speak more to the soil respiration test? So I think I can explain a little bit more about the test, and then yeah, and let me know if you need some more clarification. So the soil respiration test holds soil in a enclosed area for a few days, and then sees how much CO2 has been extracted from that soil, and that's the measure that they use to get the value that you see on your results. This is just it's not, there's no way to know what type of soil microbes might be respiring, if it's more, bacteria or fungi, etc. But this is just a bulk measure of the microbes that could be the microbes that are giving off CO2 in your soil. And I have a comment here that for raised beds, biochar could also help retain moisture and also help retain nutrients and microbes. two more questions here, and then if anybody, I can answer. If anybody else has questions, feel free to get in touch with myself after this webinar. So again, thanks for participating. We've got one question here. Apart from using tiles, what else can you do on a section of a field with poor drainage? That's a good question. I think there's just, again, a lot of soil health principles that could potentially help, not knowing kind of some of the underlying characteristics of the soil in your field, but potentially trying to minimize tillage, or again, getting deep-rooted cover crops could help with that. Those are a few things that I can think of off the top of my head. Some farmers reorient their fields, and that can also help improve drainage. And another follow-up question for soil respiration: what might account for high variability of adjacent fields? This is from Ted, and that's a good question, Ted. I don't know if I have a good answer for that. Other than saying that the soil microbial communities can be really dynamic and constantly changing, even within the same field or adjacent fields. So that's something that I think is still a limiting factor in what we know about the soil respiration test. There's a lot to learn, and we haven't found the answers for all of these questions yet. And with that, again, feel free to be in touch some more. And if you're interested in participating in this study, I definitely encourage you to fill out our survey there. So thanks again, and have a good day, everybody.